Hey everybody, today I want to look at the International Macro 2017-2018 test question 2 because this is a portfolio choice question that has a lot of overlap with the strategic asset allocation class. So really knowing how to do a question like this could be very valuable in actually two places. So in this question, our goal is to find these three terms down here, dw of w, and then these two expected values. And we're given all of this information in blue on the top, that this equation governing wealth, these three processes, and then these little facts about the stochastic process, so Werner process. It's a Brownian motion, so we know these are just true because we know that about Brownian motions. So we will begin by using this wealth process, or this wealth equation, and taking the derivative of both sides. The derivative operator is a linear operator, so we can distribute over addition, but not multiplication, and this is where Ito's lemma will come in. We know the value of dd, it's just written right here, but we need to find the value of dsf, and for that we need to do an Ito's expansion. So we do it, recalling that an Ito's expansion is going to be the first and second order Taylor expansions of this combined function. So we have to take the partial derivative of function sf with respect to s, and then chain rule. Inside we'll get a ds. Then we add on to that the other way to take the first order, take it with respect to f, and then chain rule. Outside will just be s ultimately, but then the inside we have to also have a df. For the second order, we do 1/2 times all the ways to make a second derivative of this function, and there are 4 ways. We could go partial s and then partial s again. We could go partial s and then partial f. We could go partial f and then partial s, and we could go partial f twice. So these two are equivalent. So let's just do it all at once. We'll get 2 of the same function, which is partial sf over partial s partial f. And then we need to take the chain rule. The first we'll get the ds, and then the second we'll get the df. We add to that the other 2. So it's going to be partial sf over partial s, and then it'll be d squared s. And then partial s, partial f, partial sf over 2 f partials, partial f, and you'll get d squared f. We notice though that this term is 0. This one and this one are both 0, and that's because the second derivative of sf with respect to s is just 0, and the same here. So these go away, and we're left with just this first term. So now we have a bunch of things we know the value of. This is 1. That's nice. This is just f, and this is just s, because we're actually taking the derivative of the 2 letters s and f. So we just get one of them out. Let's scroll down and get some more space, and then plug in what we know. So, well, you know, from just the information that's given to us, that's going to be f times ds, which was ss dt, plus s sigma s dzs, and that was ds. And then f was fr dt plus f sigma r dzr. And then we need to do the Ito term. This 2 and this 1/2 cancel, so we're just left with dsdf. And now dsdf, we're going to save ourselves some time by looking at how this is going to multiply out, because we need to remember dt squared is equal to 0, and dt dz anything is equal to 0, and basically anything of order dt greater than 1. So dt is dt to the 1. Remember that dz equals the square root of dt, so dt dz is going to be dt to the 3/2, which is greater than 1, so that's 0. And then dz squared, that equals dt. So how does that save us time? It saves us time when we do our foiling here. This guy times this guy is just 0, because we have dt. And this guy times this guy is also 0, because we have dt dz, so that's 0. This one and this one is 0. And then this one and this one is not 0. So the only thing that remains will be this term times this term. All right, there's getting to be a lot of junk on the screen. Let me erase some of this, and then we'll proceed. Get all this out of here. Okay, so let's do that multiplication. We're going to have SF, so this is ds df, is going to equal SF sigma s sigma r, and then dz times dz, we get dt, and the question actually tells us there's this other rho sr, which is like a covariance term. And then it tells us that sigma s sigma r rho sr is equal to rho sr. So ds df is going to be equal to sf sigma sr. So our dsf now is going to be equal to, multiplying through, we get sf times, and there's a dt here. So let's put our dt's together. There's a dt in here, there's a dt here, and there's a dt here. So we're going to get s plus r plus sigma sr dt, and then we add to that the dz terms. And I can't actually gather them because there's two different dz's. There's dzs and dzr. So we're just going to get sigma s dzs plus sigma r dzr, close parentheses. Now we can take this term and plug it back into our wealth equation. So getting some more space. Recall that wealth was equal to, change color here too, dw was equal to dd plus dsf, and that dd was equal to di dt. So let's do it. dw equals this thing up here, di dt, plus our long thing, our sf, times all this stuff, s plus r plus sigma sr dt plus sigma s dzs plus sigma r dzr. Now we don't actually want dw and dw over w, so let's divide both sides by w. Divide by w, divide by w. And the question gives us one more helpful bit of information here. It tells us that sf over w is equal to f, which implies that 1 minus f is equal to d of w. Okay, so we are almost there. We have dw over w is equal to 1 minus f I dt plus f times a bunch of stuff. S plus r plus sigma sr dt. And let's actually split this, because then we can bring the i's together. So then we'll have plus f again times sigma s dzs plus sigma r dzr. And then gathering the i's just to make it as pretty as possible, we will have 1 minus f I plus f times s plus r plus sigma sr, all times dt, plus f times sigma s dz s plus sigma r dzr. And that is dw over w. And I'll draw a nice beautiful box around it. So I'm going to cut this video here, and then in the next video we will find the expected value of this divided by dt, and also the expected value of this thing squared. So thank you for watching. I'll see you there.